Today's lesson is on outliers and box plots. Outliers are any value that falls out of the pattern of the rest of the data. Resistant is a measure of center or spread that is not influenced by unusually large or unusually small values in a distribution. A box plot is a visual representation of the 5-number summary of the distribution of a numerical variable. The 5-number summary consists of the minimum, Q1, median, Q3, and maximum. It is important to identify outliers for several reasons. They can indicate a mistake in the data entry that needs correction. They can indicate a special phenomenon that deserves to be recognized. And most importantly, they can heavily influence the values of summary statistics, such as the mean and the range. For example, the dot plot below shows the lengths and yards for each of Tennessee Titans running back Chris Johnson's runs during his games against the Houston Texans on September 20, 2009. Johnson's mean was 12.3 yards, but almost all of his runs, 13 out of 16, were below average. This is because of the two unusually large values that greatly increased the mean. Johnson's median value, however, was only 4 yards. The median is much more representative of a typical run by Johnson, since about half his runs were less than 4 yards and half of his runs were more than 4 yards. This makes the median a resistant measure of center. One common rule for identifying outliers is to see whether there are any values that are more than 1.5 IQRs below Q1 or above Q3. You will need to memorize these formulas. So the lower boundary is Q1 minus 1.5 IQR. The upper boundary is Q3 plus 1.5 IQR. For this data, our Q1 is 0, our Q3 is 8.5. So my lower boundary would be 0 minus 1.5 times 8.5, because the IQR is 8.5 minus 0, which is 8.5, and that gives me negative 12.75. The upper boundary is going to be 8.5 plus 1.5 times 8.5, which is 21.25. Do we have any outliers? We will look at negative 12.75. There's nothing less, so no lower ones. 21.25, we have 2 values above that. So the answer is yes. And the values are 57 and 91. Box plots are drawn based on the 5-number summary. The 5-number summary consists of the minimum value, Q1, median, Q3, and maximum. Calculate the lower and upper boundaries for the outliers in Tom Brady's distribution of passer ratings. In this case, his Q1 is 62.1. His Q3 is 93.4, which gives an IQR of 31.3. So my lower bound is 62.1 minus 1.5 times 31.3, which is 15.15. My upper boundary is 93.4 plus 1.5 times 31.3, which gives me 140.35. If you look, there are no values lower than 15.15, but there are 2 that are higher than 140.35, and that would be 143.9 and 148.3. B says construct a box plot to display Brady's distribution of passer ratings. If you will recall, his median is 78.9. And then we also need the min and the max. We cannot use the max because it is an outlier. So we are going to have to use the next highest number, which would be 124.4. So our min was 57.1. So I put a dot there. My median is 78.9. And my max for this one is 124.4. My Q1 is 62.1. And my Q3 is 93.4. So I'm going to go from Q1 to Q3 and draw a box. Put a line straight down for the median. So this is Q1, this is my median, this is Q3. Draw a whisker out to my min, another whisker out to my max that doesn't include outliers, and then I'll plot my outliers as points by themselves. And that is how you do your box plot. Sometimes we use the box plots to compare. So in the NHL, skaters are typically classified into one of four different positions: left wing, center, right wing, or defense. How do the distributions of goals compare for players at these positions? Use the following box plots to show the distributions to compare them. So if I look, if you go by your box plots, and this line's actually right in here, you just can't see it very well. If I draw a graph and put a little bump over the median and go out, it makes it just a little bit easier to see. Then the first thing I'm going to notice is that the defense scores a lot fewer goals. I might also notice that all of them are skewed right. An easy way to do this is to go shape, outliers, center, spread, socks. So shape, they're all skewed right. Outliers, they all have outliers. Center, as we said before, defense had the lowest center. And finally, spread. The centers have the largest spread. One more example of comparing distributions. Is soap better than hand sanitizer for getting rid of unwanted bacteria? Daniel and Kate designed an experiment to find out. Using 30 identical Petri dishes, they randomly selected 10 students to press their hand in a plate after washing with soap, 10 to press their hand in a plate after using hand sanitizer, and 10 to press their hand in the plate after using nothing. After 3 days of incubation, the number of bacteria colonies was counted on each plate. So I'm going to go ahead and draw my lines above it. Okay, so if you were comparing, remember I said socks, so shape. I would say that the number of bacteria colonies is roughly symmetric for none. And the other two are skewed right. None of them have outliers, which is our O. Center. Soap has the lowest center, while none has the highest. And then finally, spread. None has the largest spread.